Good morning, class. At this point, we're looking at algebra. We are on exercise 1 point examples. For exercise 1 point. Isn't it supposed to be 4? Huh? I think it's supposed to be 4. No, you guys hit off. But okay, sometimes you go 4 and sometimes you go off. Okay. You guys ask the English teacher? No. Why you waste your time within your English lesson? You don't talk about this stuff? What? You do maths in your English lesson? Good. Alright, factorization. So at this point we have done common factor, we have done difference of two squares. We've done trinomial factorization. We looked at perfect square trinomial, not so? Yes. So now, for the first part of this factorization, we're going to do what we are familiar with already. Okay. Several times multiply the form of algebraic expressions. Each original term is called a factorial expression. Okay, so that we know already. Determine the factors. So if you're going to look at, I wrote this. I didn't cut the solution, but this is the example on page 14. Exercise 1.9 is on page 15. They have a good reference here. Okay. Alright, so if you're looking at 2x into 2x plus 1 and x minus 1, what are the factors here? Firstly, if you're looking at the factors of 6, is going to be 1, 2, 3 and 6. Not so. All of those are factors, or numbers that are divisible by 6. Not so. So if we look at 2x into 2x plus 1 times x minus 1, then the factors of this would simply be 2x plus 1, x minus 1. Okay? Then it could be the combination of those two, which is 2x into 2x plus 1. It could have been the combination of those two, which is 2x into x minus 1. It could have been the combination of those two, which is 2x plus 1 into x minus 1. Not so? Alright? And it can be everything, which is 2x into 2x plus 1 and x minus 1, and it can be 1. I think that's behind the video there, behind the photo, but it could be 1 as well. Can you see that? Let's see what they have written here. They have even, okay, they left out the 1, but there's actually more factors than what I got here. More factors would have been, it could have been the 2 only, could have been the x only, and now it goes into more, which is 2 into 2x plus 1, and then 2 into x minus 1. Not so? Then it could be x into 2x plus 1. Then it can be x into x minus 1. Okay, is there anything else I've missed? But you guys get the idea. Yes. So not only this are factors, I've got more than them. I might be missing even factors. Okay? But at this point I don't see something that I'm missing. Okay? But you get the guys get the idea. There are many factors. Okay. Sorry? Why don't you get? You see, if I take 2x into 2x plus 1 into x minus 1. Hi. Morning. Thank you. Thank you. Okay, so if I take any of these here, I can divide it by, say, take that one for argument's sake. So it's 2 into x minus 1. So it will be divisible by. So I'll have x into 2x plus 1. Can you see that? It can be divided into, in other words. So if you're looking at the factors of 6, which is 1, 2, 3, and 6, if I take any of these numbers, it will give us a basic number without a remainder. Okay. So 6 over 2 would be 3, 6 over 6 would be 1, and so on and so on. You understand? So the factors mean the same. It is numbers that can be divided into without a remainder. Okay. So now let's look at common factors. Common factors is the first step of factorization in algebraic expression towards finding to find the highest common factor HCF of a term of the expression, and to separate the terms using distributive term. Okay. We're looking at exercise 2, and exercise 2 is on page 14. So here again, okay, see again, I didn't cut the explanation here, but to factorize 6x minus 10y. If the question was to factorize 6x minus 10y, what is common here? 2. You all see 2 is common, then what are we left with? 3x minus 5. Okay, so what are the factors here? It's 2 and 3x minus 5y. Not so. If you look at 6x, what's the factors of 6x? The factors of 6x. 6x, the factors of 6. 1, 2, 3, x. Then we can say 6x, then 2x, then 3x. All of those are factors. Not so? So they only write this as factors. Okay? But that's the basic factors. So now we're looking at the factors of 10y. The factors of 10y is going to be 1, 2, 5, 10. And y. And 2y, 5y, and 10y. All of those are factors. You mean to say all of those numbers can be divided by 10y. But the question says, so the highest common factor of 6x and 10y is 2. Can you see that? That's the only one that's in both. And of course 1 is in both. But the only one, the highest of the 2 is going to be 2. You understand?
Yes, sir.
And this is basically what we have done in grade 9. Not so? Okay. Let's carry on. So let's look at this example, and this example's on page, which page is this example on? Also page 14. It's not named example 3 and so on. I just name it myself. So example 3 on page 14. So the question says to factorize. So what is common here? 2. 2x is common. Your common factor. What are we left with? Y plus. Any confusion there? No. Okay. But of course the factors of 2xy are many, and the square factors of 4x are also a few there. But the one that is common, or the highest of both, is 2x. Okay, the highest common factor, also known as the H, C, F. Okay, so let's look at example 4, and it's on page 14. Example 4 on page 14, we are asked to factorize 3p minus 6p cubed. So what is common here? 3p. What are we left with? 1 minus 2 cubed. And we can check this if we are correct by using distributive law. We say 3p times 1, 3p, and 3p times negative 2 cubed is going to be negative 6p cubed. Remember that factorization is the inverse or the reverse of products. Okay. Let's go to the next one. I'm moving too fast. Okay. The next one says we have to factorize 3a squared minus 9a plus 12ab. What is common here?
3a.
3a. What are we left with? A minus 3
plus 4b.
4b. Okay. Again, we can check it. 3a times a is 3a squared. 3a times negative 3 is negative 9. And 3a times 4b. So they give it 12ab. Okay. Example. Then sixth example. Again, the question is to factorize. The question is to factorize a squared b cubed c squared minus ab squared c squared plus 2a cubed b squared c 4. So what is common here? A between b cubed, b squared and b squared is going to be b squared, c squared. No? Right. So I'm saying a squared, but you see here, it's only an ab. So it can't be a squared. Not so? So the highest common factor is a there. So if I take out a b squared, c squared, what are we left with? A, b, minus 1. Why 1? Because I took the whole term out as a common factor. Okay? And a, b squared, c squared plus, must be multiplied by what to give you positive 2, a cubed, b squared, c 4. Plus the 2, a squared, c squared. Yes. Okay, but you guys understand?
Yes, sir.
Any confusion? No? This is example 7. Example 7 on page 14. The question says factorize 6x minus 8y. What is common? 8. Somebody said 2. Now just looking if 2 is common. Then we got, somebody come. 8x minus 4y. But what do you notice here? You can't again have 2 as a common factor. So it's going to be 2 into 4x minus 2y. I say, hang on. 2 is again common. So it's 2 by 2 by 2 into 2x minus 1. And that gives us 8 into 2x minus 1. Not so?
Yes, sir.
But if you had seen from the beginning the highest common factor was 8. You just got 8. They got 8 as a common factor. What are we left with? 2x minus 1. You see? And both will get you 2 marks. Okay, so you always try and take out the highest common factor. That won't be wrong, but it just stays a long way of getting the correct answer there. Okay, people, let's look at the 8th example. This on page. We're still on page 14. 16. So what happened to page 15? Is that page 16? So this is for the next exercise. Okay. So that basically brings us to the end of the examples. I'll stop the video at this point. No? So the full lesson you'll find a full lesson on this exercise in the description box below. Okay. So now you guys can do exercise 1.9. You do the first column. Okay. I'll check your books again now.